Welcome to another episode of Reversing Glass. I'm Matt Rose, Field CISO at ReversingLabs. Today's episode is DNA of SSCS, or Software Supply Chain Security. I'm sure you've read in the press about all these different hacks and edicts from the executive office across many different facets, from secrets management to malware to behaviors to open source code. It's just kind of a mess. And I really wanted to kind of level set of what software supply chain security really should be and all the kind of inflection points of risk that may face you in terms of software supply chain and the best way to approach it. So I've kind of driven out a very high level SDLC DevOps process. Again, this is not comprehensive. You may have much different views of how software is developed, but this is kind of just a framework to discuss. So starting on the left, we have our development teams. We have 3 development teams that are all working on code. You have your source code repository, kind of the bank of your code, and maybe some other things, maybe open source packages live in there, but it's basically your source code repository. Then you have your CI orchestration layer that basically builds your code. Underneath the CI orchestration is the actual build that's pulling in from the source code repository and the binary repos. Then you have what comes out of the CI orchestration is the compiled package. We always use icons for things like a tub for a database. I figured the compiled package should look like a Christmas present or a birthday present. So please excuse the artistic license I took there. And then that basically is packaged up during the CD, the continuous delivery deployment process, to send it to where this application is going to live. And that could be a piece of software that's actually distributed as an install into a desktop or a server type application, or an application that's deployed to a cloud environment or a DC. DC stands for data center. So let's kind of start on the left. Again, I'm not a big proponent of shift left, but we're going to start on the left just because that's the way this is laid out. So thinking about Dev Team 1, Dev Team 2, Dev Team 3, what are they doing? They're writing code, they're testing code, they're fixing bugs. And all these little icons here within the dev teams, these are all IDEs. Okay, so we have a piece of technology that they're using. It's their native environment where you write code. And these IDEs have the potential, or not have the potential, typically have plugins so people can do different things in their application. Maybe it's a SAS scanner, maybe it's some bug checking technology, maybe it's a vulnerability management. Well, there's all sorts of plugins that basically snap into IDEs that make a developer's job easy. Thinking about this, we have 2 pieces of technology that potentially could be compromised at this point. The IDE environment itself, I haven't heard anything about that, but it is something that is of interest. But something I think is even more of interest is these plugins. That, again, is software. It is an application. It has the potential to be compromised. So there are vendors that are, writing plugins, whether that's a plugin to build, a plugin to test for security issues. There is risk. The second piece of the puzzle that we're going to talk about is the source code repository. There's tons of them out there. I mean, you're talking about the Gits, the GitLabs, the GitHubs, Visual Source Safe. Source code repository is the bank of code, and code that's usually stored and protected. The next step in this process is the CI orchestration, which handling the build and pulling from the binary repo. And the binary repo could be, have some packages, commercial packages that basically are part of the application. Somebody wants to purchase a charting package or a mathematical computation package, or you can have open source software in this environment, and then what's produced is the compiled package. Let's talk about where the risk could lie. Again, I mentioned the plugins. That's a piece of software that could be compromised. The source code repository, well, you hope it's under lock and key, but someone may gain access to that. Now let's talk about the CI orchestration layer. CI orchestration is a ton of products, but you probably heard about the Circle CI breach, where Circle CI basically said you have to rotate your secrets. Well, where do secrets come into this? Secrets in terms of the build system could be the connection or the handshake secret between the CI orchestration layer, the source code repository, or the handshake for the binary repo as part of the process itself. And then you actually go through the process to create the package. The CD, continuous delivery deployment environment, promotes that to its environment. Well, let's also talk about another way that this could be possibly compromised. The build system itself. In the SolarWinds attack, the MS build system itself was compromised. So the hackers were actually able to insert the malware into the build post all of this other testing you may have done, which, could have been, software composition analysis, SAST, many different other testing environments that you're doing for application security risks. Would have never have found this because it was post all that. It was after the fact. It was basically just inserted into the build, and let's just hypothetically say maybe they dropped it into the binary repo. So there are fundamental issues with the foundational technologies of your DevOps program, of your software development lifecycle. But then there's also the concept of the code itself. Maybe you have a bad developer that's ticked off that inserts malware or something into the package at code, checks it in, it's kind of hidden. Source code repository, maybe those secrets that were compromised by the Circle CI breach gave somebody access to the source code repository, so they're able to insert malicious code or packages into the source code repository, which were then again picked up by the build. And then you have the Circle CI and SolarWinds that are compromising this environment, the process of assembling the code and the compiled package. So there's all these different variables that you're thinking about. It's the developer. Is the developer a good guy? Is it the plugins? Are the plugins developed by a reputable source? Was somebody compromised on that end? You have the source code repository, which should be, your code under lock and key. It's protected. It's your PII. Maybe that was compromised. Maybe the build itself. Maybe the binary repos. And if you're just looking at maybe, the uncompiled code in the source code repository, or the packages, or the open source code scanned by SCA, you're going to miss things. It's all of these things. So where is the inflection point to verify all this stuff is secure? There's no malware, there's no questionable behaviors. Secrets are not only identified, but prioritized in terms of their risk and their usage. It's at this point right here. The compiled package is the final product of all of these moving parts, from the developer to the source code repository, the build environment, the Circle CI, binary repos, all these different things are happening. The compiled package is the record of truth. That is what you are deploying for usage, either by your customers, by your partners, by your employees, to cloud environments or data centers, or install on a laptop or install on a server. So when you're thinking about software supply chain security, yes, all this testing is important, but the final check has to be on that compiled package. And what a compiled package is really what you're deploying. I mean, is it a compiled ISO? Is it a WAR file? Is it a DLL, depending on the technology and the code that you're writing? This is what you need to check, because this is what people access and use, and where the malware will propagate itself. Hopefully that was informative. Hopefully you learned a few things. Again, I'm Matt Rose, Field CISO at Reversing Labs. This is Reversing Glass. Hope you enjoyed the episode.